Okay, this is example 1 from our notes. This is a single stage epicyclic gearbox. We have an input shaft here, 1000 RPM, 150 Newton meters, running a sun gear which has got 60 teeth, onto a planet gear with 20 teeth, which connects with an annulus gear of 100 teeth. My planet is attached to a link arm, this is my link, and attached to the output shaft. First thing we need to do is make up a table, and our table consists of a column for each sun gear. So we have suns, and in this case here we're going to call this one A, we'll call our link arm B, we'll call the annulus C. The planet gear I don't need to give a label to. I don't really need to know what it's doing, I just need to know what my 3 main parts are, my sun, my link and my annulus. Sun gears, I've called that A, there's only one sun gear. Link, I'm only allowed one link in a table, in this case it's B, and my annulus gear in this case is C. So first part we do for this is we now turn all plus A. So what we're going to do is we're going to take our gearbox here and we're going to rotate this thing around several times like this. So on my table all these are plus A, plus A, plus A. That's my first part. Second part is we now hold the link. Now this is really important. Hold the link. No matter what you do in your gearbox, you must hold the link arm. Now I know in the original question it says that my annulus gear is fixed. This is not what we're doing. We're cutting this gearbox out and playing with it on the bench. So we can turn everything around plus A. We're now going to hold the link arm, which stops my planet gear walking around the sun, which makes my ratios hard to calculate. So we're going to hold the link arm and then turn something else plus B. So for me, I'm going to go turn A plus B. So I'm going to turn the sun gear plus B. So on my little table, the link will do 0. My sun gear will do plus B. My annulus gear, I need to find out where that goes. So my sun gear, if my sun is turning plus B, then this will go around, it'll go around this one and around that one. You make the smooth transition for them. That one will go that way, that one will go that way. This one is going plus, this one will go minus. My annulus will also go minus because it's an internally cut gear. Right? These ones are external cuts, that one's internal. So my annulus gear will go minus B times the ratio between the two. So ratio between the two, pick the gear that I'm turning A, and I want to find out where C is going. So I'm turning this one, I want to find out where C is going. Draw a line between the two, set of meshing teeth there, set of meshing teeth there. Write the numbers in that order. It'll be minus B times 60 over 20 times 20 over 100. So back up on here, it'll be 60 over 20 times 20 over 100. Next part is just add those up. A plus B, A plus 0, A minus 60 over 100 times B, if I just cancel out the 20s. Last part is to put on the real speeds at the bottom. Real speeds. Sun gear was doing 1000 RPM. The link arm, don't know, and my annulus gear was doing 0. Now all I need to do is use these in order to solve the value of A and B. So A plus B equals 1000 and A minus 60 over 100B equals 0. A is equal to B times 60 over 100. Substitute that back into there. B times 60 over 100 plus B equals 1000 B into 60 over 100 plus 1 equals 1000. B is equal to 625. Back over here, that implies that A will equal to 375. Both of these are positive values. So now my final thing is, what is my output speed? My output speed, back up here, my output speed was the speed of the link arm, which I said was B. So in column B, the output speed is this number here, given to me by whatever formula this is. Now in this case it just says A. So this output speed here must be 375 RPM, coming from the value of A that we established down here. Second part is I want to find the torque on the output and the what they call the fixing torque, the torque on the third part of the epicyclic. To do this for a simple epicyclic where something is held, I can do this simply by constructing a free body diagram. So here is a free body diagram for my epicyclic gear. Input shaft, output shaft, 1000 RPM, 150 Newton meters. Assuming that I've got 100% efficiency, then power in equals power out. If I have an efficiency, then power out will equal the efficiency times the power in. So 2 pi 1000 over 60 times 150 is equal to 2 pi 375 over 60 times torque. My torque output will equal 400 Newton meters. So on my original diagram, my input velocity is this way, my input torque will also be in that direction. On the output, we've already established that my output velocity is positive, it's in the same direction as my input velocity. My output torque, we will find, will be in the opposite direction to the velocity. Now, simply with these, if we take a really simple shaft, obviously my velocity at both ends are the same. If my input torque is that way, my output torque, to satisfy my free body diagram, must be that way. So as I go in, energy is going into the shaft when my force and velocity in the same direction, and energy comes out of a shaft when my force and velocity are in opposite directions. So that's why this is opposite to the direction of the velocity. So on my input they will be the same. On my output, then my torque will be in the opposite direction to the velocity. So this torque is 150, this torque here is 400. Sum of torques must be 0. I must have a torque on my housing through here, which is also going this way at 250. 150 plus 250 equals 400. 400 going clockwise, 400 going anti-clockwise.